So where are we at? Like, or do we have like a couple more weeks to go? Or
Yeah, we're almost completed. I'm not going to go through ever full calculation on residential. What we're going to do is I'm going to do this week. I'm going to do a full standard calculation. Next week I'm going to do an optional. Okay. Uh,
okay,
and then I'll explain whenever you get into multifamily, it's exactly the same thing. You just multiply by the number of units. So it's,
okay,
I don't want to go through everything. And then we'll get into finishing up commercial. So we're probably about 2, 3 weeks away from knocking everything out.
okay.
Last week we finished up the overcurrent protection devices, and this week we're doing the residential, where we went through all the individual loads. When we get over to commercial, I'll do exactly the same thing. Now we're going to go through all them loads again, and we're going to explain everything one more time, especially when we're dealing with the cooking equipment and explaining how to use the notes and everything one more time. And then
Gotcha.
we'll go through the full calculation next week. They'll come in to fill in the blank calculations, and then after that, we'll start in and we'll do pretty much. We'll probably put in a full night next Thursday, and we'll go through all the commercial. Then we'll do a couple of commercial calculations, and just wrap it up from there. Okay.
Okay, sounds good.
So uh, this week we're getting into looking at the residential, and this is where we were talking about where we started. If you remember, I said we have 6 loads groupings that we're going to do. Now, one of the things I want you to remember here is if you're already getting to where you're going to test on the 2023, this is 2020. When we get to those loads, and I'll go over and read that in a little bit when we get there, but um, the uh, when we look at our 2023 version that we have, we're going to add one more group to this, and that's going to be your EVSE. Okay,
Okay,
so instead of 6 groups, it'll be 7 in 2023. Now, remember, there's certain things we want to do. We're gonna do the general lighting and receptacle and small appliance plus laundry load, and then we'll do our cooking equipment loads, and then you got your dryer loads, and then you got your largest between your heating and AC load. Those loads you want to do individually. Then you remove all them loads, and anything that's left is going to go in your fixed appliance load. And then your last load will be your largest motor load out of all of that. Okay.
nice.
And that's the way you want to remember to set this up. We're going to do sort of the same type of principle when we get over and start looking at our commercial loads. Okay. And doing commercial industrial calculations. Now,
Right.
this one, looking at the illustration, we're going to give you some known values here. We're going to tell you we got a 3,500 square foot dwelling unit. We got 2 small appliance circuits and 1 laundry circuit. Now, we know we looked at this or last Thursday. We said anytime you're going to calculate and you're going to do your square footage for a dwelling unit, you're going to look at 220.14J, and it's going to tell you to take that at 3 VA per square foot. And then when I get to my small appliance load and laundry load, you're going to look at 220.15A for the small appliance and B for the laundry load, and you're going to take that at 1,500 VA for each one. Okay?
Now,
So
question for you: is that on the 2020 reference or is that the 2023? Because I thought they changed that a little
that
bit.
it's the 2020 we're doing right now.
Okay, gotcha.
Now, yeah, 2023 will be a different section for the
Gotcha.
it won't be 220.14J. Okay.
Okay.
Now, so, and I don't want to go quote more sections, people get confused. Okay, so I'm going to stick it on
Yeah.
2020. But what I am going to do
Gotcha.
is maybe not next year, but the next we'll do the 2023 version of this. Okay.
Okay.
Now, what you're going to do here is you're going to take the VA per square foot, which is 3,500, and you're going to multiply that 3 VA per square foot which is going to give you 10,500 VA. Then I had two small appliance circuits. Each circuit's good at 1,500 VA. That'll be 3,000 VA. And for the laundry circuit, you add a 1,500 VA. So you'll take that at one time. Now, you add all of that up together, and that's going to give you 15,000 VA. Then you're going to look over at table 220.42, and you're going to look at the very first one will say dwelling units on the left-hand side, and it tells you take the first 3,000 VA at 100%, then you take the remainder up to 117,000 at 35%. So I'll take the remainder, which is 12,000 VA at 35%. That gives me 4,200 VA. Add that up together, and that'll give you a total demand load of 7,200 VA. Okay? So hopefully everybody got that in their homework. Pretty simple once you get the step-by-step procedure down. You'll see this is not really hard to know. The only thing you want to remember here is 220.14J, 220.52 A and B, and table 220.42. That's it. Okay? Then when you come in and you start looking at doing your cooking equipment loads, this is pretty easy because I'm going to go over, and I'm going to look at table 220.55. And when you come over and pick this up, if you're not more than 12 kW, but you're more than 8 3/4, you're going to use column C. Okay, so here I've got a 10 kW cooking equipment. And you come across, pick up your appliance. For one appliance, come over, it tells you it's good at 8 kVA. So just put that at 1,000, get it in VA form. That's 8,000 VA. Okay?
Right.
Now, before we get to column A and B, I want you to look. If you look at that table, right above column A and column B, you'll see demand factor, and it'll have a percent in parentheses. That means these values that are going to be listed here are going to be percent values that you're going to use. Okay?
Right.
So if I come in here and I look at this one, I've got two 3 kW ranges. Okay, now let's just take a look. If I look at table 220.55, I pick up two ranges, and I look here, I got 3 kW ranges, so I'm less than 3.5. It's going to tell me that I'm going to take that at 75%. Okay? So basically, what do I got here? I got 6 kW at 75%. That's going to give me 4.5 kW multiplied by 1,000 to get it in VA form. That's 4,500 VA. That's pretty easy to follow so far. Okay?
Yeah.
Now I look at column B. I've got it 8 3/4. Okay? So I'm above 3.5 up to 8 3/4. I got one unit. It tells me to take it at what? 80%.
Yeah.
So I'll take that range, that oven there at 8.75 kW times 80%. That'll give me 7 kW. Multiply it by 1,000 to put it in VA form. That gives you a total load of 7,000 VA. Okay? Now, let's take a little further look here. Now you're going to have to start looking at the notes. And if you can have more than one range here, but in note 1 it says if it's over 12 kW to 27 kW ranges, and these are all have to be of the same rating. Okay, so I've got one here. Okay, so I'm going to take one range and I'm going to subtract that by 12 kW. Okay, that's going to leave me 4 kW. Now, what does it say here? It says for ranges individually rated more than 12 kW but not more than 27 kW, the maximum demand in column C shall be increased 5% for each additional kilowatt or rating or major fraction thereof for each individual range that exceeds 12 kW. Okay, right. So that means that's why I'm subtracting by 12, because I'm exceeding 12 kW.
Yeah, by 4, right?
So that leaves me with 4. And it says for each additional kilowatt rating, I take it at 5%. So that's going to give me 20%. Now, looking at this, I've got one range. Okay, so if I look over in column C, that's where it's referring me to. I come across it tells you that one range is good for 8 kW. Okay. So I take that 8 kW at 120% because it's 100% of the load plus the additional 20%, and that'll
Right.
give you a VA rating of 9600 VA. Okay.
Right.
Now let's look at note 2. Note 2 is where you're over 8 3/4 through 27 kW ranges, and these are all of unequal ratings. And what I want to point out here is these are not on the same branch circuit. These are individual circuits going out to each range. Okay?
Right.
So I've got a 12 kW range, a 16 kW range, and a 24 kW range. So I'm just going to add all them together, and let's read what it says, and then you'll understand, because I have to get something that gives me an average value here. Okay.
Right.
So let's see if it tells me to do that. It says for ranges individually rated more than 8 3/4 kW and of different ratings, but not exceeding 27 kW. Look here. An average rating value shall be calculated by adding together the ratings of all the ranges to obtain the total connected load. And look here, in parentheses, using 12 kW for any range that's rated less than 12 kW. We don't have that. And then it says, and divided by the total number of ranges. Okay, so let's do that first. I add them all up. I've got 3 ranges, divide by 3. My average rating there is 18 kW. All right, now let's see what else it says. It says, then the demand in column C. We're using column C again. Now this will be interesting because I have 3 ranges, so that means I'm going to base this off the 3 ranges that are in column C. And it says it shall be increased 5% for each kilowatt or major fraction thereof by which this average value exceeds 12 kW. Well, let's look. I
Looks like you got 6.
Subtract by 12. So that's going to be my average. So I'll take the 18 average rating minus 12, give me 6 kW, multiply it for each additional kilowatt rating by 5%. That gives me 30%. Then I come over and I look at the table for 3 ranges, come all the way across, and it'll tell me it's good at 14 kW. So I'll take that additional 30%, add it on to the 100% of the load. So that'd be 14 kVA times 1,000 times 130% to put it in VA form will give you 18,200 VA. Okay.
Nice.
Now the great thing about this so far is everything I've stated up to this point has fell in line with exactly with what the text says. Okay. Right. I'm showing you where it tells me to do that. Now watch this next one. This one here is where I'm not going individually. This is all being tapped right here. Okay, so
oh yeah, that one causes some major controversy there.
Right. And you got to look at this. If they were individually, I'm in note 2. But if I have an installation like this where I'm tapping off, now you're looking at note 4. And what does note 4 say? This is where you get into your branch circuit load, and it says, it shall be permissible to calculate the branch circuit load for more than one range in accordance with table 22055. Then it says the branch circuit load for one wall-mounted oven or counter-mounted cooking unit shall be the nameplate rating of the appliance. The branch circuit load for the counter-mounted cooking unit and not more than 2 wall-mounted ovens, all supplied from a single branch circuit and located in the same room, shall be calculated, look here, by adding the nameplate rating of the individual appliances and treating this total as equivalent to one range. Okay?
Oh, nice.
So you look, you're going to add it all together and treat it as one range. So if I look at column C up there, what is one range? 8 kW there. Okay?
Right.
And that's in column C. So let's just do an average. Add them all together. Based on the nameplate rating there, that's 30 kW. Subtract that by 12, 18 kW. You take it for each additional kilowatt at 5%, it's 90%. Then you treat it as one range, which is in column C, 8 kVA. Take that 190%, and it'll give you a total VA rating of 15,200 VA. Okay?
Right.
So that's about the simplest way to explain it. All right? Now, This is where you're going to look at table 220.54. And it'll tell you when you look at that table up to 4 ranges, you can take it at 100%. Well, when you look at this, I've got a 5.5 kW dryer. Now, I do want to point one thing out because right there in the illustration, we show the dryer at 5.5 kW and we say, look at 220/54. If that was a 4.5 kW, you have to kick it up to 5 kW. Okay, so that could be a little trick on the test. All right, so I just want to point that out. So all I'm going to do is take that one dryer at 100%, and what do you get? 5,500 VA. That's it.
Yeah.
That's about as simple. Now, if I had 5 dryers, now I'd have to put a percent on that at 85%. Okay?
All right.
Right? Now, other than me showing you a non-coincident load between the heating and AC, basically what we're going to do, we're going to look at this illustration, and right there at the top left-hand side, let's take a look at that. We've got an AC unit and heating unit. Drop that from the calculation. Let's go down. Water heater stays in the fixed appliance load. Oven and cooktop, drop it. Water pump, disposal, compactor, microwave goes into the fixed appliance load. Dryer load, it kicks out. Blower motor in the calculation. So I'm looking at this. If you see this on the test and they got all these loads here, don't even pay attention to what the voltage is and all of that. You're just looking at which loads you're going to drop at this point. So we're going to drop the AC, the heating, the oven, the cooktop, and the dryer. Everything else goes in here. So looking at this, we had a water heater. It's good at 6,000 VA. We had a water pump. That's good at 1,600 VA. Then we had a blower mower, good for 700 VA, a disposal at 900 VA, a compactor at 1,200, and a microwave at 1,000. Just add them all up together. That'll give you 11,400 VA. Now, what's going to happen, you're going to look at 220.53, and it tells you here, it shall be permissible applied demand factor of 75%, the nameplate rating of 4 or more appliances. Well, we're looking here, I've got 4 or more naturally, so I can put a derating factor of 75% on that, and that'll give you a total VA load of 8,550 VA. Okay? So that's how you do, and then you got your last load here, which is a non-coincident load, and you look over at 220.60, and when you pick this up here, this is your non-coincident load. And basically, it just tells you whichever is the largest between the two, since they're not both going to be operating at the same time, you can take and drop the smaller of the two. Okay? So I've got a 20 kW heating unit here, and I got a 2.5 kW AC unit. Put them in VA form. Naturally, the 20,000 VA heating load is the largest, so that'll be your total load for the VA. Okay? And then we got one more load, which is the largest motor load. All right? Now, you'll go over and you'll look at 220.14C, and it'll talk about loads for motor outlets there shall be calculated in accordance with the requirements of 430.22, 430.24, and then also 440.6. So they're also looking at your AC loads and everything else, whichever could be the largest here. In this case, we're just going to tell you pump motor's the largest. And it's 230 volt single phase, and it's 5 horsepower. Okay? Now, in order to determine this is if you go over and look at 430.6A1, it tells you when you're sizing your conductors over current devices that you'll use one of the tables, in tables 430.247 through 250. In this case, since it's single phase, we'll be looking at table 430.248. You pick up the 230 volt column, come down and pick up your 5 horsepower. It'll tell you it's good at 28 amps. So I'm just going to add an additional 25% on there. Now, you could do the calculation and just know what the largest motor is and just do it at 125% for sizing the conductor. It could be that simple too. But we're just taking one, adding an additional 25% on there. That'll give you 7 amps. I need to take and get it in VA form. So I'm going to multiply it at 240 volts. That'll give me 1,680 VA. Okay.
Right.
And then here's another one. Um, let's say that I looked at it and my 120 volt motor was the largest motor. Okay. So I could look at this and say, all right, well, I've got a 115 volt single phase 2 horsepower motor. Of course, since it is single phase, I'm looking at table 430.248, pick up the 2 horsepower, come down, or 150 volts, then come down, pick up your 2 horsepower. That'll give you 24 amps. Take it at 25%, gives you 6 amps. It's a 120 volt circuit. Multiply it by 120, that'll give you 720 amps. So what we're trying to point out here is that the 120 volt or the 240 volt could be the largest motor. Okay.
Right.
Now, that brings us into showing you how to do a full calculation. All right. And I broke this down a little bit where it's easy to follow. Actually, it's on a full page, but I had to sort of finagle it a little bit so everybody could see how to do this. All right. Now, this one here, we're going to determine the VA in amps for a dwelling unit. And I said the easiest way to do this is get everything in VA form. Okay.
Right.
Now, here are your given loads we're going to give you here. We got a 2,800 square foot dwelling unit, 2 small appliance branch circuits, and 1 laundry circuit. Now, I do want you to point one thing out right there on that top side there. You'll notice we got a little bullet, like a little check mark thing there for sizing the phases and neutrals. We will put those down on all of ours. It makes it easier for you to follow, to know which loads go where. Okay.
And I'm gonna just point out they're not really phases; they're actually legs of one single phase.
Oh yeah. All right. Now let's look at this. Here's my single phase loads, 120 volts. I've got a 2,600 VA water pump, a 1,000 VA disposal, 1,200 VA compactor, 1,600 VA dishwasher, a 1,000 VA microwave. Now here's my 240 volt loads. I've got a 6,000 VA AC unit, 10,000 VA heating unit. Now, when I'm looking at this problem, I can already tell you what is going through my mind. That's my non-coincident loads. They're not going to be part of my fixed appliance load. Okay.
Right.
I'm looking at a 5,000 VA water heater. That's going to go over into my fixed appliance load. I've got a 12,000 VA oven, a 16,000 VA cooktop, and a 5,000 VA dryer. Those don't go in the fixed appliance load. I've got a 800 VA blower motor. I know that's a fixed appliance load. So
Right.
you can see in my mind here, I'm already deducting loads that I'm going to do separate, and everything else is going to go in to 220.53 for the fixed appliance load. Okay.
Right.
So we're going to look at doing 6 groups here. So we're going to do the first group here. We call them columns to call them out, but it's still 6 loads. So right here, I've got my general lighting and receptacle load. Now we know, we just looked at 220.14J. We're going to take the square footage of whatever the dwelling unit is at 3 VA per square foot. So that's going to give me 8,400 VA. Then I said, look at 220.52 A and B, and for the small appliance and laundry loads, you take 1,500 VA for each. So I had 2 small appliance. That'll give me 3,000 VA. 1 laundry load, that's 1,500 VA. Add that up, that's 4,500 VA. And if you total all of them out, that's going to give you 12,900 VA. Okay? Then I said the last thing you need to do is look at table 220.42, and it tells you for the first 3,000, take it at 100%. That'll give you 3,000 VA, and all the VA that's left up to 117,000 VA, you take it 35%. That'll give you 9,900 VA left at 35%. Will give you 3,465 VA. Add that up, and that'll give you 6,465 VA for the phase load and neutral load. Okay.
Right.
See the little check mark there? We put it there so you don't screw up.
Yeah.
Right. And I'll tell you, go look at all these other publications out there. You won't see this. Okay.
Yeah.
setting this up to where it's easier for you to follow and understand how to put those loads in the places they need to go. All right.
Dude, this is actually giving me a good idea for next week's Willy quiz. I'm gonna actually do like when certain appliances were invented.
Oh God, I hate that. Okay. Well, you got that'll be interesting because then we got to start looking. When do they put the definition of outlet in?
Yeah. And
Ooh,
when the water heater was invented, the electric
yeah,
water heater.
that'll be interesting. All right, now this is interesting here because now I'm getting into the cooking equipment. So let's look at what we got. We got a 12,000 VA oven and a 16,000 VA cooktop. Now, right away, I know I've got 2 units here. Okay, but the interesting part about this is I've got 2 units that are of different rating. You see that?
Right.
That's
Mm-hmm.
something you need to pay attention to because if they were of the same rating, I would be where? In note one. Note
Yep.
two is where I have different ratings. Okay?
Right.
So all you're going to do is the same thing. You're going to add those up. That'll give you 28 kW. Okay? And then you come across 28 minus 12 gives me 16 kW. Each additional kilowatts taken at what? 80%. Okay?
Yep.
Now, the interesting thing about this is when you look at this, it tells you then you go over and look at column C, and you did an average rating, didn't you? So that means you're going to use how many uh, ranges here? You're going to go to one. Okay,
Right.
so I'll take that at 180%. That'll give me 14,400 VA. Now look at here. Now everything that was left. Oh shoot! I can't believe I just did this. I actually forgot to put the dryer load in. God dang! That's the thing. I was doing this late last night and I just missed it. Okay, let me go ahead and do the dryer load for everybody. So I had a 5,000 VA dryer. That's going to be 5,000 VA. That should have been dropped down below with the cooking equipment load. And then everything else that was left, other than the heating and AC, goes where? The fixed appliance load.
Yep.
Okay? That's what happens when you're cutting and pasting all of this stuff, trying to make it fit into a presentation. So
Yeah.
I had
Dude, you make very little mistakes for the amount of material you go through. So
well, it's
I 100% salute you. I mean, the amount of flack that you take for like few mistakes, I'm like that's no problem.
well, it's
Nobody
actually
else nobody else goes out there like you do.
well, that dryer is actually in the book. I was cutting pasting trying to get it on the screen, and that's why I missed it. It was
Okay.
just it's in the book. It just here I was trying to cut. Oh no, there it is. I got the dryer load right there. I dropped it down here because I had to fit it somewhere. So there it is
Okay.
there. Okay, I should have put the dryer load in before. I think I was trying to fit everything so everybody could see it.
See how that goes. You thought you made a mistake, but you were wrong. So
Well, it just
you got it right.
there's just so much that you're putting in here. You're trying to get it all in, and these, I'd like to be able to just post the whole thing up there, but you can't see it. So,
Right.
but everything that was left, we had the water heater, water pump disposal, compactor, dishwasher, microwave, and blower motor. Just add all those VAs up together, gives you 13,200. I had four more, so I take it at 75%. That gives me 9,900 VA. Now, I do want to point something out here. If you notice, we did this on purpose. Right there in step one for calculating the fixed appliance load, see where we got the little check mark beside it?
Yeah.
So we're telling you there, we got the water pump, disposal, compactor, dishwasher, and microwave. Those are going to go onto your neutral load when you calculate. Okay? And then we go, what is the largest between the heating or AC? Well, it's pretty simple to look up there. 10,000 VAs more than 6,000. So
Okay.
10,000 VAs is the largest. So now I'm going to look at which one of those is the largest motor. Well, looking at them, I can see there the water pump's the largest. So,
Right.
and that's interesting because that's 120 volt load. So I'm going to take that
Right.
2600 VA at 25%, and that's going to give me 650 VA. Okay.
And that goes against the neutral load too, since it's 120 volt.
What? Say it again. It goes against the
So,
neutral load.
like, cause you were talking about the neutral load. I haven't heard that before. I just didn't know if that was part of the neutral load. The
It's for the phases and the neutral. It'll be the largest.
Okay.
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 Well, not for the neutral load here because there's no neutral load there for that water pump.
Ah, got you.
Okay.
Cause it's balanced.
Yeah. And
Okay.
then what you'll do is just add all them loads up where we have the bullet beside it and add them up, and that'll give you your total VA, and then divide it by 240, and that'll give you 193 amps. Pretty simple. And that's why I tell everybody just follow the loads. And if you follow the loads, you'll see that you can get exactly what you need. And then let's take a look here. Let's look at the neutral load. Well, if I go back, you'll notice it's the same thing. Right here, it was 6,465 VA. Okay.
Right.
I'm going to come back here. I'm going to put that there. Now, the next thing I need to do is looking at my cooking equipment load. Well, let's go back. My cooking equipment load was what? 14,400. So I'm going to come over here and I'm going to put this on here. You go look at 220.61. It tells you take that at 70%, and that's going to give you 10,080 VA. Okay?
Gotcha.
And then you come over here and then you look at your fixed appliance load, and look at there. I put all the loads there that were checked back here. Let's go back and look right there. So I've got 5 loads checked here with the VA. So I'm just going to put them loads right there. 1, 2, 3, 4, 5. And then of course I have 4 more, so I can take it at what? 75%. That'll give me 5,550 VA. And then I've got a dryer load. 220.61 tells you take it at 70%. And then we do the largest motor load at 25%. Add them all up, divide it by 240, and there's your amperage size. Pretty simple. So if I look at this and I come back here, let's come back. I've got 193 amps. Okay, let's come back here. If I go over and I'm just going to size based off table 310.16, the next size above that is the 3-aught, which is good for 200 amps. If I look at table 310.12, it'll actually allow me to put a 2-aught on there. Okay?
Right.
Then if I take
and that's the 83% rule, right?
It's the 83% rule, but the table's already done for you where you can go in and select the size conductor for it.
Gotcha.
Basically, you're getting to go down a size usually is what it's telling you. And then your neutral, what's the next size above that? It's a number 2, and I think what's it good for? 115 amps. Yeah. So that's how you go about doing a full calculation. Now, when y'all get into doing this in your homework next week, you'll see all the values are given up here. So as you look at this, and you'll notice we got the check marks beside everything so you don't screw up. You got the bullets and the checks, so you'll know how to size the neutral and the phase conductors. And one of the things,
you know what I call that, James?
What's that?
Easy math.
Yeah, it is when you really start to understand it, and you just have to know where to go get everything. When you're doing the full calculation, you will remember your cooking equipment and your dryer load. You need to get that neutral load at 70%. Go look at 220.61. Everything else stays the same. That's the only add-on you really have here. Okay? Right. And as I'm looking at this problem, what am I thinking about here? I'm going to look at this and I'm going to say, I'm going to drop that AC heating unit, the oven, the cooktop, and the dryer. Everything else is going to go into my fixed appliance load. Now I'm going to do my general lighting and receptacle load. I know 220.14J, I'm going to take it at 3 VA per square foot. And then my small appliance and my laundry load are taken at 1,500 VA. And then I take those however many there is. and then the first 3,000 is taken at 3,000 VA. All the remaining VA up to 117,000 is taken at 35%. Then you come down and start looking at doing your calculation for your units here, for your cooking equipment. So we're going to have that set up for you, and then we even put the 70% there for you to rate in order to do that. Then we come down and do the dryer load. We set it all up in order for you here so you can go through and do the calculation. And then everything that was left goes where? The fixed appliance load. And then notice there, we even set it up in step 2 for you to do the 120 volt loads. Okay?
Right.
And then do your largest motor load, then come in and start filling all your loads in and size your conductors. And that will get you into next week, and then we'll start